This is your practice test for Chapter 8. Choose the most reasonable measure for the length of a winning softball throw, 50 meters or 5 kilometers. 50 meters is approximately, there's about 3 feet for every meter, so that's about 150 feet. 5 kilometers, 5,000 meters, that's over 2 miles, 2+ miles, so I think we want to choose 50 meters on that one. The weight of a shot put, 8 pounds or 24 ounces. So let's see, 24 ounces is a pound and a half. That's pretty light for a shot put. If you've ever picked one up, you know they are surprisingly heavy for their size. They're about the size of a softball, but they're very dense, and they weigh 8 pounds, or 4 kilometers, sometimes 8.8 pounds. Number 3, so the answer is 8 pounds on number 2. Number 3, a large bottle of Gatorade, 32 fluid ounces or 6 fluid ounces. Well, there's 8 fluid ounces in a cup. So 6 fluid ounces is less than a cup. That's a measure you're probably familiar with. That's really light for a large bottle of Gatorade. 32 fluid ounces would be 4 cups, which would equal a quart. So a quart, it's a large bottle of Gatorade. The answer is 32 fluid ounces. Number 4 and 5, solve and rename units as needed. So this is a little bit like adding tens and ones. You add one place value first, and you add the inches first, then you add the feet. So 9 and 5 makes 14. So this would be 14 inches. And 7 and 8 is 15, so it's 15 feet. But 14 inches is more than a foot. 14 inches equals 1 foot, 2 inches. So we have to add 1 foot, 2 inches to 15 feet. And that would give us 16 feet, 2 inches left over. 16 feet. Let me erase that part and make that just a double hash mark there. 16 feet, 2 inches. I'll subtract 44 yards, 3 feet, 6 inches, and subtract 11 yards, 2 feet, 8 inches. You can't do the 6 feet minus the 8 inches won't work. So I'm going to have to regroup change some feet to inches. And 1 foot is 12 inches. So when I do this regrouping and make this 2 feet, I have to add 12 inches to the 6 inches. I'm not going to just put a 1 by the 6 and make it 16, because 1 foot is not 10 inches, 1 foot is 12 inches. So this becomes 12 and 6 or 18 inches. Now I'm set to subtract. I can do 18 minus 8 is 10 inches. 2 feet minus 2 feet is 0 feet. I could write 0 feet in there, but I don't need to. And 44 minus 11 is 33. So it's 33 yards, 10 inches, or 33 yards, 0 feet, 10 inches. The metric prefixes, there's a few clues that can help you. For instance, anything that ends in an I is less than 1, it's a fractional amount. And if it doesn't end in an I, it's more than 1. And then there's some of the letters give you clues about the meanings of the numbers. Number 6, deci, it's less than 1, so it's either A, D, or F. The DEC is a hint that it has something to do with 10, like a decade. So for both 6 and 10, they have something to do with, number 6 and number 10 have something to do with the number 10, either 1/10 or 10. So number 6 has to be A, 1/10, because it matches, the DEC matches the 10. Milli, you just have to memorize it, that is 1,000th, that's F. Hecto, it's more than 1, ends in an O, starts with an H, just like the word 100. It's letter B. Centa, the I indicates it's a fraction. 1 cent is 100th of a dollar. That's D. Deca sounds like decade. That's E. In kilo, the only one left is letter C, and kilo indeed does mean 1,000. In the conversions, there's no way around it that you have to either have it in your journal or you have to memorize some of these facts. So you have to know that 1 mile equals 5,280 feet. And you know you're either going to multiply or divide 5 by 5,280. If we kind of reason through this, we're going to take the 5 miles. And we're going to multiply. I have taught you that you're either going to multiply by a fraction or divide by a whole number. But we have to have the unit miles in the denominator part of this. This is 5 miles over 1. Because we want to have our units cancel, we want to change feet to feet. And so if I put that 5,280 feet, there's 5,280 feet for every 1 mile. This number is worth 1, because 1 mile here is 5,280 feet, and 5,280 over 5,280 is 1. So I'm multiplying 5 miles times 1. But the 1 here doesn't actually look like a 1. It looks like 5,280 feet over 1 mile. But that's worth 1, because 1 mile down here is the same as 5,280 feet. And 5,280 feet divided by 5,280 feet is 1. So what happens is these units cancel. And when we do 5 times 5,280, you get 26,400. And I'm running out of space there. Let me just move that over some. Yeah, I can erase this. No, I can't erase it, but I'll put the 0 here. And the label that's left is feet. Just mark that out there. So the answer is 26,400 feet. We're going to convert 7 kilograms to hectograms. HG is hectograms. And just putting a chart here for grams where we go from kilogram, hectogram, decagram to gram, the basic unit of mass, decigram, centigram, milligram. This can be a tool that we use to make our conversions. So we start at 7 kilograms, and we're just going to move over to hectograms. And to do that, we move just one space. This is like one space, but kilogram to decagram would be 2. So we start with 7, and we actually take the decimal and move it one place. So that would become a 70. And that helps us know to go from kilogram to hectogram, we have to multiply by 10, and the 7 would become a 70. So 7 kilograms is 7 hectograms. Number 15 is changing 6 and 2300ths of a liter to milliliters. I'm going to talk about 2 ways to do this problem. Every liter is 1,000 milliliters. So you could multiply 6.23 times 1,000 to get the answer to this question. Or you could use the little chart that we have down here, which is similar to the other charts that we had, where we can say that we're going to start here with 6.23 liters, and we're going to move to milliliters, which is going to move the decimal 1, 2, 3 places. So this decimal will move 3 places. So if we start with 6.23, with the decimal here, we have to move it over 3 places. So it goes 1 place behind the 2, 2 places behind the 3, and 1 more place behind a digit that's not there. So we have to put it in there, which means we have to annex a 0 here. So it would be 6,000, I'll just put it right here, 6,230. Or if we look at it this way, 6.23, we'll move to 62.3. It should be deciliters, sorry. Put the L in there. It's 62.3 deciliters, 623 centiliters, and 6,233 milliliters. In number 16, we're going to change 8,754 grams to kilograms. There's it takes 1 kilogram is 1,000 grams. So we're going to divide by 1,000, which means we're going to move the decimal 3 places to the left in 8754. And when we move 3 to the left, it goes from behind the 4, 1, 2, 3 places. So it's going to fall between the 8 and 7. If we use the little chart to help us make sense of this, when we go from kilogram, which this should be, that's not quite in the right place. This 8,754 should actually be right here, because it's no, that was in the right place. Let me start that over again. We're going to go from grams to kilograms. So we're going to move to the left. We're going to move 1 place, 875.4 decagrams, 2 places, 87.54 hectograms, and 1 more place, 8.754 kilograms. You may intuitively know how to change a pint to fluid ounces, or maybe you've memorized that there's 16 fluid ounces in the pint. If you've got that, you just have to double 16 to get 32. But you do have to have some basic knowledge of the conversion factors. You have to know that a pint is 2 cups. So there are 2 cups for every 1 pint. And if you have to know that a cup has 8 fluid ounces. And then if you want it, this is a more formal way to do this problem, and you can see how the units will cancel. We can take the 2 pints, multiply it by 2 cups for every 1 pint. This is worth the number 1 because every 1 pint is 2 cups. So this is really like 2 cups divided by 2 cups. This is like the number 1 because every 8 fluid ounces is the same as a cup. So we have the same value in the numerator and the denominator. So we're basically saying 2 pints times 1 times 1. But because these ones are in different form, it's going to change the form of our answer. We can do some canceling of labels. Pints cancel here, and cups, top to bottom, cancel, which we want to see that because now we're left with the label that we desire, fluid ounces. 2 times 2 is 4, and 4 times 8 is 32, and the label is fluid ounces. So it's 32 fluid ounces. We've done a problem like this before, changing meters to kilometers. It's a certain number of thousands of meters to kilometers. Every 1,000 meters, every group of 1,000 is 1 kilometer, and we can ask how many groups of 1,000 do we have here. It's dividing by 1,000, so we're going to move the decimal to the left 3 places, and it'll fall between the 8 and the 5. So we're going to see the answer is 8.56. You can stop right there, or put the 0 there if you want to. Don't have to. Or we could use a little chart, and there's more to this chart, so put the rest of it in here. We don't need it. 8,560 meters to change to kilometers. We go from meters to kilometers. Decameters would be 856, hectometers 85.6, and kilometers 8.560. Our job in number 19 is to change 82 ounces to pounds and ounces. We have to use the fact that 1 pound is 16 ounces. 1 pound, 16 ounces. So again, we'll keep in mind that this value is 1, so we're really doing 82 ounces times 1. But the 1 looks like 1 pound for 16 ounces. 82 times 1 is 82. And then we're going to do, we can put 82 over 1. 1 times 16 is 16. Ounces cancels here, which leaves pounds. And 16 goes into 82 5 times, remainder 2. Again, show that division. Oops. 16 goes into 82 5 times. 5 times 16 is 80. Remainder 2, and that 2 is 2 ounces, so it's 5 pounds, 2 ounces. In number 20, the fact that you have to know is that 1 ton is 2,000 pounds. And we're going to change 8,800 pounds to tons and pounds left over. So we start with 8,800 pounds. Multiply it by a conversion factor, which is going to put pounds in the denominator here and tons in the numerator. And the fact is that 1 ton is 2,000 pounds, so this has a value of 1. Because I could substitute 1 ton down here for 2,000 pounds. It would be 1 ton over 1 ton, which equals 1. Then I can do some canceling here. I'll put a 1 here. But pounds cancels. So the label that's left is going to be tons. 8,800 times 1 gives 8,800. And 1 times 2,000 is 2,000. And our label will be tons. And the math that you have to do, let me scoot this up a little bit. Is 2,000 divided into 8,800. And that'll go 4 times. Remainder 800. So that would be 4 tons, 800 pounds. Number 23, we're going to change 3 1/4 ton to pounds. The conversion factor that's convenient to use here is that 2,000 pounds is 1 ton. And 3 1/4 is what we're going to change it to. So could possibly write this as 3.25. It's pretty easy to work with 3 1/4 times 2,000, which is what we're going to have to do. Now this might look a little strange, but it might also make it plainer. This is all over 1. So the tons are going to cancel. This label's going to cancel. And when you do the math of 3 1/4 times 2,000, you'll get the answer to this problem. And it'll be a certain number of pounds. You can actually do 3 times 2,000, get that answer, then do 1/4 times 2,000 and add it to 3 times 2,000. So let's try that. Think about what's 3 times 2 and put 3 zeros behind it. So that would be 6,000. Then think about 1/4 times 2,000. 1/4 of 2,000. 1/4 of 20 is 5, so 1/4 of 2,000 is 500. So we can add 500 to the 6,000, and it would be 6,500 pounds. Think of it, another way to think of it possibly is that the 3 tons, this 3, every 1 ton is 2,000 pounds, so you have it 3 times, that's 6,000. And then a fourth of a ton is 500 pounds, so 6,500. The speed of sound is about 1,100 feet per second. How many miles per hour does sound travel? We'll start with that. We're given 1,100 feet per second. Every 1 second. We have to change feet to miles. So we're going to say that there's 1 mile for every 5,280 feet. And then we have to change seconds to hours. 60 seconds in a minute and 60 minutes in an hour. And we might have worked with this enough that you know there's 3,600 seconds in an hour. 3,600 seconds for every 1 hour. So labels that'll cancel here are feet and seconds, and what remains are miles per hour, which is what you want here. So we're going to get 1,100 with no label times 1 mile, there's our 1 mile, times 3,600 with no label because the seconds canceled. When you punch this in and divide it by 1 times 5,280 times 1 hour, so miles per hour, when you work all this out, do all that multiplication, divide by 5,280, you get your answer of 750 miles for every 1 hour, which is 750 miles per hour. That's the speed of sound. Max is paid a monthly salary of $3,696. He works 21 days and works 8 hours each day during the month. How much does he make per hour? So we need to figure out how many hours he works in a month. 21 days, 8 hours a day, 168 hours. And we want to know dollars per hour. So he's going to get $3,696 and 168 hours. So it's a division problem, 3,696 divided by 168. And when you do the division, whether you do it by longhand or pencil and paper or calculator, you get 22, which is $22 for 1 hour. This is like a unit rate like we did in chapter 7. So you have to say dollars for 1 hour. Divide 3,696 by 168. $22 for 1 hour. Compare the customary and metric units, so sort of your sense of how they compare to each other here. A box of nails has a mass of 4 kilograms, is closer to 9 pounds or 2 pounds. Hopefully you remember that every 1 kilogram is approximately 2.2 pounds. So 4 kilograms would be 4 times 2.2, or 8.8 pounds, so it's closer to 9 pounds. Number 2, the distance from Greenwood to Philadelphia is about 100 miles. Is it closer to 75 kilometers or 160 kilometers? You might also remember that the 1 mile run is about 1,600 meters. If you're a track person, you kind of know that. 600 meters is about a mile. And 1,600 meters is 1.6 kilometers. So a mile, every mile is about 1.6 kilometers. So 100 miles would be 100 times 1.6, which is 160. So it's about 160 kilometers. Number 26, the low temperature for Friday is predicted to be about 10 degrees Celsius. Is this closer to 35 degrees Fahrenheit or 50 degrees Fahrenheit? The formula that you're going to use to change Celsius to Fahrenheit would be that the degrees Fahrenheit, which we don't know, is equal to 9/5 times the degrees Celsius, which we do know is 10, and then add 32. So we're going to plug the numbers in the formula. Fahrenheit equals 9/5 times 10 over 1 plus 32. And this will reduce. 5 goes into 5 one time and then 10 two times. So then we get 9 times 2 is 18. So 9 times 2, 18. And 18 added to 32 is 50. So it'd be closer to, it is exactly 50 degrees Fahrenheit. Number 27, it's 273 kilometers from Baltimore to New York. If you travel the distance in 3 hours, what would be your rate of speed in kilometers per hour? 273 kilometers in 3 hours. This is a unit rate question again. So 3 goes into 273 91 times. 91 kilometers for every 1 hour is 91 kilometers per hour. The winner of a 400-mile race had an average speed of 180 miles per hour. How many miles per minute would this be? You don't really need to know that they went 400 miles. You just have to change 180 miles per hour to miles per minute. So we're going to start with 180 miles for every 1 hour. And we have to change to miles per minute. So we're actually going to keep that miles as the length, as the distance in this comparison between distance and time. But we have to say how many hours, 1 hour is how many minutes, which is 60. So when you do this, the hours will cancel out. You'll get 180 miles in 60 minutes. So our label is going to be miles per minute, and it's 3 miles per minute, moving pretty fast. You might have known that 60 miles an hour is a mile a minute. I'm going to write MPM, miles per minute. So you're going 3 times as fast. 3 times 60 is 180. So you're going 3 miles per minute instead of 1 mile per minute. The total meat consumption of each American averages 180 pounds per year. How many ounces is this? We have to change pounds to ounces. 180 pounds times 16 ounces in 1 pound. So I can put this over 1. The pounds will cancel. So this shows that you have to do 180 times 16 to get the answer. And 180 times 16 is 2,980. And the label is ounces. So there's our answer.